constant is 1 is less than or equal to m is less than or equal to 105. That means I cannot give a number more than 105. And x is between n and 0. Y is between 0 and m. And the array size at any time is between the n and 1, where I is between 1 and n. Similarly, v is between 1 and m, where 1 is, where j is lesser between 1 and m. It is guaranteed that the values in the array are distinct. It is guaranteed the values in the array are distinct. So both the arrays, in the horizontal array as well as the vertical array, it's guaranteed as distinct. So now the first line contains integer n, the second line contains integer m, the third line contains integer x. The size of the array is h. Each of the next 6 lines contains integer h of I, where y is between 0 and n. The next line contains integer y. The size of each of these next lines contains integer vij, where 0 is lesser than j, lesser than m. So if I give the sample input as 0, that means there is only one test case where the size of the window with vertical bars is 3 cross 3. I cut horizontal bar at 2 positions, row number 1 and row number 2, vertical bar at column 1 and column 2. So the output I get is 4. Okay, this is one of the examples where it's a 6 cross 6 bar. And I'm removing a horizontal bar at 4, vertical bar at 2. And I need to write a Java program for this. All right. So team, we come here again, we try to draw a 3 cross 3 bar, which is shown here in this figure. This is 6 cross 6 bit, but we'll draw a 3 cross 3. Right. So 1, 3 cross 3 bar is 1, row number 1, row number 2, row number 3. So this is 0, and this is 1, and this is 2, and this is 3. Right? So this is 1, and this is 2, and this is 3. Now suppose what the problem says is that if I do a cutting, as the slide said to me before, that if I have a 3 cross 3 prison door, that is 3 horizontal bars and 3 vertical bars, I will cut at position 1. That's only one position, and that is row number 2. Similarly, vertical is only one position, that is column number 2. So what I'm going to do is I'm going to cut here at 2, right? So I'm going to cut at column 2. What is my task here? My task is I need to find the maximum size of the window. So that I will be able to find out the length and breadth of the total window. So let's go through this. Now what you see is that there is a horizontal bar cut here at row number 2 and at column number 2 it's also cut. So there is only one position that is horizontal row and there is one at horizontal 2. But what does the answer say when you happens this? What is the answer you get? So when he says that you have a 3 cross 3 and then he says that the counts are at horizontal 2 and vertical 2. That means Sam removes horizontal bar 2 and vertical bar 2. So horizontal bar 2 is removed and vertical bar is removed here, right? So when you remove the vertical bar here, that means this is having a gap because you removed the horizontal bar. So what does simply mean? This simply means that, you know, this is your gap. This is your gap. Let's take a filler and then fill it. Control Z. Let's take a color picker and then fill it. Oh man, it's filling the whole thing. Okay. So this is the one. That means that is 4 by 4. Pardon me, my apologies for the drawing, but what I meant is that it should fill this also. So that means I would get a 4 cross 4 here, right? Yes. So my window is 1, 2, 3, 4. Let's imagine a blind person. And then he will have goggles, right? 1, 2. Where's the goggle? And then you have, let's say, how would he measure that this bar is cut or not. He's just going to wave his hand here, right? And if there is no vertical bar, then this is empty, right? That means he's going to count 1, 2. This is empty. Now what he does is that since we know that it is cut at 2, he's going to count this. He's going to simply hold his hand and wave his hand from here to here, which is row number 2. Similarly, so that means the count here is 2. What's the count here? It is 2. Horizontal count. Count is 2. Then let's imagine that he's going to, put his hand here, right? When he finds that there was no vertical bar here, similarly when he puts it hand this way, let's take this, and then when he's waving this way, he finds that there is no gap, right? And he knows that it is cut at 2, so he's finding there is no gap here. So that means the vertical count here is 2, right? Okay, we have done some analysis now that we have a bar which is 3 cross 3, and the horizontal line is cut at row 2, vertical line is cut at 2. And what we observe is that a blind man tries to put his hand and he feels, oh, there's a huge gap here. That means the column 2 is cut. There's a huge gap here. That means 2 is 2. The count will be 2 here. Similarly, when he goes to rows, what he finds is this is cut, right? So this is also 2. Now when I multiply this horizontal count 2 into vertical count 2, the gap is 4. How am I going to resolve this problem? So basically what I am going to do is I'm going to have a for loop. And inside that, another for loop, right? So in the first for loop, I will start from row 2 and I keep on counting. I keep on touching here. Now here there is a bar, right? So I need to put the information that there is a bar here. I need not count. But when I reach here, I observe that there is no bar. So I need to increment the count. But how do I store this information? I will store this in a list. Let's call that as list of vertical cuts. which I need when horizontal counting. Then I will store another one. So when I'm counting the columns, what I observe is this, the number of columns. Here I have horizontal rows, I did not count, but here I found that the count horizontal bar is cut here. So, that means I need to have some information to store that this is cut. So I will have a list of horizontal cuts. Horizontal cuts. So now I will have two for loops, a list of verticals, a list of horizontal cuts. When I am looping inside the outside for loop, I'll start looping in such a way that I'll start from a row and end into the total length. But when I start in the row, I start counting based on, since I'm counting the number of cells, I'll refer the list of vertical cuts. And I'll store the max of that. Simply I go into the for loop. When I go, I'll start with, I will not start with 0. I'll start from column 2. And I keep on counting. So the moment I'll refer this horizontal cuts list, and then I count. And at the end, I multiply both of this. So far so good. We have analyzed how to resolve this issue. Now let's go to the Java program. So we're at the point where we were trying to analyze. We wanted to prepare a list of vertical cuts and a list of horizontal cuts. This, I can have a list or I can have an array, right? So what do you mean by that? I'm just going to have, instead of list, I'll have this as an array. Array of vertical cuts. Similarly, I can have an array of horizontal cuts. Horizontal cuts, right? So I decided not to have list. I decided to have horizontal cuts. Let's go back to the Java program. Okay, here we come. Now, as I said that we're going to get the size of the horizontal array. Sorry, I mean the width and height of the prison bar and the array where the cuttings would be done, right? This is the array. So what I'm going to do is that I need to store only the positions where it is cut. So what I do is very simple. I go through the horizontal length here and I will store wherever I will store this as 0 because bar is not there. So when I'm counting X, that means I need to store the position of, that means I'm pointing the columns, right? So I need to see whether the horizontal bar is there or not there. So I'm going to loop through this. Whatever is entered here, I'm going to enter the value of that here, which is the array. And similar thing I'm going to do for the columns also. That means, say I'm going to get here, I will discuss, right? That I'm going to get a 3 cross 3 array, right? Then I'm going to have only one position, which is row number 2, and only one position, which is column number 2. So right now what is happening? Here, N and M are 3 and 3. Then here, this is size only 1 for horizontal. Vertical also size is 1. So let's come here now. Let's do one pass. So what happens now? This becomes 1, x of y1, y of y1. It's going to go through this loop, and then we are going to store the values here. So it stores only 1 right here, 1 value. That is row number 2. Here also it will store only 1 value, row number 2. Now what we're going to do is we're going to max this. We're going to loop this to get the maximum horizontal gap. So wherever it is greater than 0, that means there is no count, right? Let's go back here. That means there is a vertical bar here when I'm counting. But here it is not there. So I'll point this as 1. I'll count here, but I'll not count here. So that is what I'm doing here. And I will store the max of these values. That means what is stored here is 1. Ox is 1. Now similar thing I do for y. So y is also stored as 1. Remember this, that when I count, if there is a vertical bar cut, my count starts here as 1, right? But I need to increment because there are 2 houses here. So I add a 1 at the end. Even though I return the max of this and this, I return ox plus 1 into y plus 1. So I have constructed the logic. Now this is the way I take. Now first I take the sides. First I take n and m. That means I take the horizontal size, array size. This is horizontal array cut. This is vertical array cut. This is horizontal array size. And this is vertical array size. Right, so let's run this program now. When we run this program, I need to enter width, which is 3. I need to enter height. I need to enter number of positions. I'm going to cut the row at 2. Horizontal positions. I'm going to cut the row at 2. And what is my answer? Yes, the final answer is 4. Right. So far so good. Let me try another one, which could be useful. So now we will try another window where we'll have multiple positions. That means I will have a 6 cross 6. I'll cut at 3 positions, 2, 3, 4, and 1 and 2. Let's draw the diagram first to make things clear. Rank 2, 3, save. So now 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, right? And 1, first row, second row, third row, fourth row, and okay. So now we see the figure of 6 crosses. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5. That means I need one more. Here you go. And this is the one. So this is 0. This is 1. This is 2. This is 3. This is 4. And this is 5. Right? 0, 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6 is correct. So I need one more row. 6. Yes, you need one more. So 1, 2, 3. This is 6. Now, so far so good, right? 1, 2, 3, 4, 5, 6. Row 1, row 2, row 3, row 4, row 5. We need one more. Then this is one which is closing. So 1, then next is 2, next is 3, next is 4, next is 5, next is 6. Right, but we need one more again. It's here. Complete the diagram. Now this is x cross 6, the problem was given. And we are going to cut at 3 positions here. 2, 3, 4, right? Row number 2, row number 3, number 4. Row number 2, row number 3, row number 4. Number 2, row number 3, row number 4. Vertically, you're going to cut only at one position, which is column number 2. So column number 2 is here. Okay. That means now let's bring the blind man. And oh, sorry. So what am I supposed to do here? There's 4 inside this, right? Blind man. Why it is looking red? Yes. Let's take a stick. How about the blind man read? The blind man, if he starts at row 2, right? Here it is not cut. So there is no count. Here it is not cut, but here the count starts. So cell 1, cell 2. I got 2 cells. He's going to start again at row. Again, he got 2 cells here. Right. Now, that means he got 1, 2, 3, 4. Let's see vertically. Vertically, that means this is over. Now he's going to count like this. 2 and 3. Now this is over. Here he's going to count. The count starts here, right? There is no vertical part. So for him, here it starts, no. Here it starts counting 1, 2, and 3. That means 1, 2, 3, and 4. So 4 cross 4. That means if I bring here my filler, This is the one. This is the one. This is the one. This is the one. Similarly, 4, right? And I got 4 columns. Column wise, rental wise, I got 4, right? So that means I got totally 8. Let's go back and see if our theory works. I'm going to execute once again. And let's take the inputs. Now I have width as 6, height as 6, and it's at 3 positions, 2, 3, 4, and at 1 position, which is 2, right? Yeah, 1 position is 2. No. How can the answer be 4? Something is wrong. I gave item in row, enter vertical array size. What exactly happened here? Now, when I started executing this, here I am supposed to get, at one place I am supposed to get 2, right? Yeah. And one place I'm supposed to get 4. So what went wrong? Let's check this. Let's try to print the max for horizontal and vertical. Max of vertical is 2, right? And max of horizontal cut is 2? No, it should not be 2. It's 3. What went wrong here? So we saw that the answer went wrong, right? When we were trying for another combination. But let's analyze what we did. Again, we made a array, which I talked about here, right? Let's open. So we made an array of vertical cuts, but what was the length of array of vertical cuts? The area of vertical cuts is going to store the position of all the flags of the width and height of the store, right? That is what I'm doing here. I stored the position of the cuts. First, as initialize this as 1 everywhere in those arrays of vertical cuts and array of horizontal cut. So I'm going to call this as array to store position of horizontal cuts as flags, and also array to store position of vertical cuts. Then start storing positions. Start storing the positions. Flags in the positions. So I started storing this. And then what I'm going to do is that I will store the positions depending on the H and Y are the arrays, right? I go through this and I store the positions. And then what I do is I take out the max out of this horizontal as well as verticals, and then I add one, right? And you know very well why I'm adding one here, because when I go from here to here, if there's no vertical bar, I have to count this as 2, right? When the count begins. So that is the reason I'm adding 1 here. And let's execute this now once again and see what's going on. 3, 3, 1, 2, 1, 2. So answer is 4. We need to check for another 1. 6, 6, 3 positions, 2, 3, 4, 1, 2. Yes, we got the answer as 8. If you find this interesting, do give me a like on this below button. And I'd be happy to have one more episode on how to use a standard algorithm for this.